Look at this mess. So recently I uploaded this video on building my own computer from scratch. So for that we had built this basic circuit, as you can see in this paper. Last time last time in the video I had put a 9-volt battery, a resistor and a LED on a breadboard and calculated its current flowing through, but my calculations were wrong. They weren't wrong, they were just slightly off. I had to multiply this current by 10, which would give me the exact current value. And as you can see the mess around me, that you might be thinking what I'm doing. So I got this lithium ion batteries from my box of scrap, which weren't charged, and I removed the upper coating and the upper coating, and so I was charging them, but this one isn't charging. These two batteries are charged. Yeah, so I got the charger from that scrap box also, but this both cell got charged. But then when I'm trying to charge this, it's not working. So I opened the box, and you can see drill machine. Why? Because the bottom the bottom screw from here was not opening because it's a tight space in there. Here it got easily removed. I didn't have to do any much because the space is more. So I checked this charger. This wire is burned from here, and this one also. So in order to replace this wire I need a soldering iron, which I do have here. This soldering iron, but it's not getting hot. So when I I remove this element from this soldering iron, and I check. Wait a minute, let me show you. I found out. So you can see the element is removed. So I removed it because I found out that soldering iron is only disconnected from the wire. So I tried to strip down the wires. As you can see the trash collected over here. I tried to strip down it so I can open the wire, and now I need I need to check which one is the live wire and which one is neutral. So I turned on the switch. I have this tester over here. If it glows, it is a live wire. If it doesn't, it's a neutral wire. This one is neutral. Wait, I did check this. Oops, the current is flowing. I got a shock. Now it is not. It's a very high voltage, high current. So do not try this at home. Basically, I'm trying at home only. Telling you not to try. Like, do not try with your bare hands. You might see blur video because it's very close to my camera. So this is neutral. This is live, but it's not doing it. Maybe I need to touch both. Stay away. Oh, I do not have a proper stand. No, it's not even happening. Never mind. So the mat. So this is cut, and you can see here. Wait, it's a lot of mess over there. Uh, See, this is disconnected. The diode is also disconnected, so it was not hitting. I mean, I think so. Maybe it is overheated or something. I don't know, but it might have broke. So sorry, sorry for the yawns. So I think I need to buy a new soldering element. I saw the video on YouTube that if the element is not heating up, but there is current in the wires, which electrocuted me for a moment. Uh, so that means the element is not working. So I need to I can replace this, but if only I have the what I. So guys, finally I cleaned up the mess, and so I was telling that I need some money to buy a new soldering iron or the kit. If I have to buy, then I will buy the full kit, because we never know what I need, but not for now. So the previous video was on the day zero. It was I have taken the challenge to build my own computer from scratch. Today is the day one of the challenge, and but it would be very boring, not boring to just make a series out of nothing, the, like it would be very boring just to build something small, and from smaller to bigger, and just explaining what I'm doing. So in the twist is that whenever upload, whenever if it is day zero, I build a basic circuit, then I would upgrade the circuit to something better. So this is how I want to build the CPU, not just like going straight from basics to logic gates and all, like all small stuff is just wiped out, like it's just wiped out. So I want to, and even that I will also put some bonus things in that. And this series is not just based on building a CPU, but I will also I will also upload some like build something else also in between the videos, like between the series or in the series, there will be bonus projects also, like not bonus, but basically it would be like, if I'm building something and I need to build something before that I build that thing, that then that would be in the video also, like it would be in the future videos also. So this is what my plan is, and today is day one. Here we start. So guys, I'm going to rewrite this everything. We are going to restart it from very big, not not very beginning. We will restart it from where we left yesterday, because I want to make sure everything is correct and perfect, so we do not make mistakes, like big mistake. I do not have a proper holder right now. Whatever I have, this mobile stand is very loose from its hinge, like from the screw, so it, even if a slight vibration would make it fall, so I would have to adjust it every time, like you can see. It will either fall that side or this side. Stop this, pause the video and show you after I'm done the calculation. And I will explain you manually. So guys, last time we had done is that we created a simple circuit using a battery, resistor and a LED. I also had shown a breadboard module, power supply module, which is not necessary in a simple circuit. We can just directly connect battery to the resistor and the LED, but do not try to connect LED directly to the battery, because it will blow out, because LED doesn't have that much of resistance to cut off means minimize the current flowing through it. A 9-volt battery would give us some 0. Like we calculated it, I measured it from multimeter in the previous video, that it comes to be 0.4 amperes or milliamperes. Like that small amount of current is also enough to blow out the LED. It will heat up so much that it will just never glow again back. It won't work. So our simple circuit had this. I don't know why I raised this much, but let's create another. Let's do let's make some changes. So if you are able to see, then okay. So this is where it all starts now. In a simple circuit, what we need is a battery. Battery contains some chemicals, like there are specific. Some batteries have manganese, cadmium, something. I don't like. Some batteries are lithium ion batteries, so it contains lithium ion, which on chemical reaction with another chemical like zinc or whatever, nickel or whatever is in the battery, how it is made, like what elements are used in the battery, like during the manufacturing. So some use nickel ion, some use cadmium or something, chromium, like chromium is not used, I think so, like hmm. Lithium ion batteries, everyone knows. So lithium ions, they produce during the chemical reaction or the electrolyte reaction, it produces electrons. There are free electrons, which produces some current. Electrons flow from negative to positive, but the current flows in the opposite direction of positive to negative. This is not like you might not see here. I am doing positive and this negative. The bigger rod is like a bigger line is the positive and this negative. So current flows in this direction, but to in order to produce electricity or to generate electricity, a current needs to flow from positive to negative. Inside the battery, it cannot flow because it's not, both are not connected, they are disconnected, like they are two separate terminals. Like, so this is basically battery. We will start with not 9 volts directly, we'll start with 1.5 volts alkaline, not lithium ion, alkaline. So alkaline has different types of alkaline are there are nickel ion alkalines. So we are basically using alkaline based 1.5 volts. We'll be starting with Tinkercad because I don't have enough material to start with this 1.5. I do have 9.9 volt battery, but we do not want to get there. We want to upgrade also, like the twist I was telling. So going from 1.5 volts wouldn't give enough power to glow our LED fully bright. So we are not using 1.5. So this is what I was telling about the upgrade. So we will slowly upgrade the battery until we'll get the LED glowing. So after upgrading, we'll come to 5 volts. Basic 5 volts is needed to glow the LED. Now for the current to flow, we need a path. So wires are introduced. So we upgrade the circuit to wires. So this allows the current to flow, but here there is no circuit, like there is no connection, like I have not given the full connection. Why? Because it's a open circuit, but it's open circuit. So if I close this circuit, it will become closed. And if I it if it becomes closed, it will become a short circuit. So in simple terms, a short circuit would burn the wire. Like, there is no resistance. Wire does have a resistance if it is a thicker wire or a longer wire, but it's like resistance is minimum, bare minimum, like it's not even there. So we do not close this circuit, so we need to add some resistance first. So this is, we add some resistor, not resistance. We add resistors which creates a resistance. Resistors of, for now we use 220 ohms. That's also fine. 220 ohms not gonna blow out, like make the wires burn. For 5 volt of battery, it may burn the wires if it is higher than like 9 volts. 12 volts would be like burning the wire. Like, it would even burn the wires. Like, wire would start burning. Resistor wouldn't burn because it can handle 12 volts of the battery power supply. For 220 ohms, like if it is less than 220, like 110, then maybe the resistor also start burning. First the resistor would burn, then the wires would burn if short circuited. Like, then to know that the current is actually flowing into the circuit, we add a led which glows. Led symbol is not this. It is like a diode with two arrows going outside. So it's a led, any color, any color. So this is the simple circuit. Now we know that voltage, like the battery has some voltage which is currently 5 volts right now. A resistance is 220 ohms. 220. So current will be some x. We define it as x. Why? Because we do not know what's the current. In order to know the current, we need to go through this this triangle over here. V I R. So V is equals to I into R. R is equals to V upon I, and I is equals to V upon R, because it's division multiplication. Division multiplication. So I think so it is called as Pascal triangle. So now to find current X flowing through this simple circuit, we simply do is V upon R, which is equals to 5 upon 220, and which is equals to 0. 4, it will be 0.44, like we measured last time. So this would be ampere, like we measured last time, and now the answer is correct, because last time what happened was we used 9 volts. mm, uh, we use 9 volts, right? So the answer should be the same. It should be the same. No, answer won't be same. No. Answer won't be same. It would be different answer. Then different this answer. So this, we got the correct answer to be 0.44 when we use 5 volts of battery, but we had 9 volt of battery. So we'll do that calculation also. This is basically our case 1, case 2, it's sorry, my bad. Let me pause it. And guys, finally I made some changes. I've added power also to know how much heat loss, voltage is lost during the heat. Voltage is converted to heat, which is, also known as some power. And this LED has some power of some watts, which is, here you can see the calculations. I've changed the, like, I've changed the voltage readings to 3 volts to get uh, so proper calculations. It's not 0.4 40 44 amperes, milliamperes. So as you can see, I'm using Tinkercad here. Oops, the paper flew away. So I'm using 3 volts right now, which is giving me 4.9 milliamperes. Voltage across the resistor is 1.08, so the voltage across the LED would be 3 minus 1.08, which is 1.92. Here, wait. Lot of mistakes later. So after so many mistakes, trial and errors, I've got the conclusion that the power outcome of the LED is 0.0094 watts, as we are taking 4.9 milliamperes, as you saw in the Tinkercad software. We are giving 3 volts, 4.90 milliamperes, which is 4.9, which divided by 4.9 divided by 1000 gives you 0.0049 amperes. So this is the this is the first circuit we built so far with proper calculations. We'll also try with 5 volts. With 5 volts will give me 13 point. So if I do, as you can see here, I'm doing 5 volts. It is giving me 13.5 milliamperes. Like, even if I set here, doesn't matter even if I set here, because it will just give me, if I set even 4, it will set to 13.5. I don't know why it's happening like this. When I set this to 1, so this, if here this thing is 5 ampere and this is 5 volts max, like max it can give, and 5, this can give 30 volts max. So if I do 30 volts max, it will give me max of 124 milliamperes. Even if I reduce this, it wouldn't stop, because it would like go off, and boom, 30 volts LED will blow off. Like, using 30 volts it will blow off. So this is the first thing we have done so far. But now, aside from this, keeping aside the calculations part, we are not into that. We are more interested into building. We do not want, we would need to know the readings afterwards, not the calculations, because we have measuring instruments like voltmeter. We have power supply, like Tinkercad has almost everything which we need. If I don't have in physical, then Tinkercad is best. Currently I'm recording from my phone, but I'll make sure that I will record from OBS, using OBS Studio, because that's the best. So last time not last time, yesterday we had also done with the case 2 using a 9 volt battery. So that's not the max. Now we will use this power supply thing, which gives 30 volt supply and max of 100 and 128 amperes. Like, not 128, what's the max, 124 milliamps divided by 1000 is 0.124. So 9 volt gives 31.1 milliamp current. and throughout the voltage stays the same until unless it is the if the current is in if the circuit is in parallel, like it if the resistor was in a resistor cannot be parallel to the LED, it has to be in series, then only it will work. Otherwise it won't. But if I connect two LEDs in parallel, then current would be divided into two. So if I'm using 331.1 milliamps, so it will get divided into two depending on how much resistor I use for each LED. Suppose I use 220 ohms resistor for one and 330 ohms for another, then it would be is it voltage? I'm confused between voltage and current. So yeah, I got it. So voltage is divided only when the components are connected in series, like it gets subtracted according to its load, how much load it's taking. So currently you can see the resistor is taking 6.84 volts and giving out the rest. So this would remain the same when current would remain the same. So if I go 1.5, 1.5 is very less. 1.5, let's go to, so it will give 2 volts will give 841 microamperes, not milliamperes. If I go 2.5, then it will give 2.81 milliamps, which is close to 3 volts, because there is no 2.5 volt batteries or like this, like this power supply, the power supply is like acts like a regulator, voltage regulator. So we can go from 1 volts every 0.0111, like slowly we can turn it to 30 volts, and which gives 124 milliamps of current. That's the max we can use in this power supply. Batteries are limited. They come in different voltage readings, coming from 1.5 to 3 volts, 3.2, 3.7. 3.2 and 3.7 are only lithium ion batteries, not in nickel ion batteries, the alkaline batteries. There is 1.5 and 9. In lithium ion there is 1.5 also, there is 3.2, 3.7, 5 volts. There is no 5 volt, but we can make a 5 volt battery using a power battery pack management system, like management system, which regulates the voltage, a higher level voltage to a lower 5 volt voltage. So a voltage regulator would convert 9 volts into 5 volts. 4 volts of the battery is 4 volts is just deducted into heat loss, like it converts into heat. That's the thing. That's the basics. Now coming from the basics, this this is the part 1 of the basics. I will take this to part 2 also, which will come next time. So till then, thanks for watching this video, and please do subscribe. Thank you.